Okay, so it says triangle ABC. So the first thing you should be doing is labeling the angles ABC, and then it is congruent to triangle DEF. The angles need to be corresponding AA, BB, CF. Then it's giving us some measurements that we need to label. So it says that line AB equals 18, so that would be AB. BC is 23, and AC is 9x minus 23. Next piece of information, DF equals 7x minus 11. DE is 3y minus 1. And it's not giving me this last piece of information, but it should be congruent to BC, because they are corresponding sides. Okay, so we are going to find what x and y are congruent to. Okay, so we have, first of all, we know that AC and DF are congruent. So we would set up 9x minus 23 equals 7x minus 11, because these two sides are congruent. So from there you would just solve for x. So I could move 23 over, cancel that out, bring down my 9x, and bring down my equation. So negative 11 plus 23 is equal to what? Does anyone know? $12. Alright. So from there you're going to bring your x over. So 7x subtracted from both sides. 2x equals 12. Okay, go ahead and divide, get your answer. Very good. So x equals 6. Okay, we still have to solve for y. So based on that example there, how do you think we're going to solve for y? Very good. These are going to be corresponding sides. They are congruent, okay? So we would start by writing 3y minus 1 equals 18. Then you would bring your 1 over. 3y equals 19. And then I would have to divide, which this is going to give me a decimal. Which would be, if you had a calculator, you would divide that. That would be 6.3, and the 3 continues, so we would put a line over it. Okay, so again, you have to know what corresponding sides are. In this case, we had AC was congruent to DF, and DE was congruent to AB. Alright, so on the bottom it's dealing with angles rather than sides. So it says triangle MEL is congruent to triangle BAH if the measure of angle L is 56 degrees, the measure of M is 21 degrees, and the measure of A, which is this angle right here, is 7y plus 5. Then it goes into line measurements. ML is 25, so I'm going to write that in a different color. TS. Oh, I think that's supposed to be EL. EL is 14. Okay, and then ME is 31. BH is 4x minus 11. Alright, so again, we are looking for corresponding parts. We need to find the value of x and y. So if I'm trying to find x, I'm going to look at the equation 4x minus 11. What would be the corresponding side on this first triangle to BH? ML. So line ML is congruent to line BH, because they are congruent triangles. So you would set up the equation 4x minus 11 equals 25. Go ahead and solve that equation. Alright, what should I be doing to both sides? Adding 11, and I get 4x equals 36. So I'm going to divide by 4, which gives me what number? 9. Very good. Okay, so my second equation is going to involve the y. So if I'm looking at 7y plus 5, this is an angle measurement. Okay, so this angle is corresponding to what angle on this triangle? Angle E. Those are going to be corresponding angles, right? So we could say that the measure of angle E is congruent to the measure of angle A. Do we know what E is at the time? No. So we would have to figure out the missing piece, which we should know that we're going to do what with these two numbers? Add them first. And then I would subtract from what number? 180. Good. Okay, subtract that number. What do we get? 103. Very good. Alright, so my missing angle is going to be 103. So I'm going to go ahead and plug in my 103 into this equation. 7y plus 5 equals 103. From there you should be subtracting, canceling out the 5. Okay, and that gives me 98. And my last step is to divide. Which would give me 14. Okay, so when I have algebra with congruent triangles, you must know corresponding sides and angles in order to solve that. Okay, so from there we're going to glue this in later, but right now we're going to move on to the next page, which is steps to triangle proofs. Alright, so the booklet that you got with all those papers, this is going to go with that. This is just like the steps that you use when you're trying to prove triangles are congruent. Okay, so the first thing that we should do here, let me see if I can find this paper, there it is. Alright, so these are the steps. So it says to label the picture, like what we just did with those triangles where we labeled the vertices and the angles on them. That's your first step, is to label. The first statement in your proof should be the first given. When it says given, that means we should know what that means because we've seen it with parallel lines. That is a given information about the triangle, like angle A is congruent to angle E or whatever it's telling me. And the reason also should be given. So we reach a congruency Once you find a congruency, you move to the next given and repeat step 3. If you have used up all of your givens, look for a reflexive side or pair of vertical angles, which we saw yesterday with those double triangles. Okay? Once you have 3 congruencies, you determine if the triangles are congruent by side, 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 angle, angle, side, angle, 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 side, or last one would be HL, which is hypotenuse leg. Alright, so you have these papers that you got when you came in. This is going to be like the booklet we did for transformations. It should be in this order, so I'm going to start from the front. This obviously is your title page, so this is your first paper. SSS proof 1, and then this one says proof number 4. So this is the first page, it needs to go first on the table. And it says page 1 in the corner. Got that one down? Next we have SAS proof number 1. That's going to say page 3 down here. Okay. Then we have ASA proof 1. Notice it's going kind of like odd numbers. 1, 3, 5. Hold on. Okay, then we have page 7 right here. So go to page 5 and then page 7. Okay, got it? Alright, then you are going to fold like this. Here, which might not really look exactly correct on the front, but as long as everything's folded in. Okay, and then like last time, you will staple like here and here. Okay, so just one on the top and one on the bottom, and that second one didn't go. So, alright, so that's how it will look when you're done. And then we're, of course, not going to finish this whole thing today, but we're going to work through it. Okay, so how this works is it's giving us this given information. We have to prove that the 2 triangles are congruent. The only way that you can prove that 2 triangles are congruent are with the 5 postulates that we have listed and that we learned yesterday and the day before. So on this one, obviously, we're trying to prove using the side, side, side postulate. So at the bottom, you can see that there's kind of like a bank. This is what you're using when you're putting in your reasons and your statements, okay? So the first piece of given information is that line PQ, it's right here, is congruent to line ST. So if I'm looking at this triangle, I should be giving those 2 the same congruency markings. Okay, it says to make sure that you're labeling the picture, all right? So down here on my statement, I'm going to mark that out because I am going to be using that on my first statement. And again, how do I know that information? Because it is what? Very good. So I'm going to mark out given at the bottom since I'm using it. And I'm going to write that into my reasons. Alright, so the next piece of information is that line QR is congruent to line TR. So I'm going to give them a different congruency marking. I'm going to mark it out on the bottom because we're using it, and I'm also going to mark out given. Because again, that is given at the top. Alright, so the next part is telling me that R is the midpoint of PS. So I'm going to use that. That's going to be my next piece here. And I kind of abbreviated it, but it still means the same thing. R is midpoint of PS. And again, that is given. So I've used all my given information. I've stated all of the given information at the top, and I'm marking it out. Since R is the midpoint, which is here, that means that these two segments must be congruent, okay? Because that is the definition of what midpoint does. It cuts a line in half. So we would say here that segment PR is congruent to segment RS. Or SR, same thing. And that is the definition of midpoint. Therefore, if all three sides have been proven to be congruent, we can now say that the two triangles are congruent. Because all of these sides are congruent. So it is proven by the SSS postulate that the two triangles are now congruent. Page here we have the, it should say SAS, that's proof 2, and we are, actually no, that's not AS, sorry, that's going to be, hold on, what page is that? I can't even see, SSS still, okay, so this is another side, sorry. Alright, so based on the information, it says L is the midpoint of JN, so obviously that's going to be the first thing that we're writing here. And that is given. Okay, so since that is given information, what does that tell you about the two segments here? If L is the midpoint. If this is the middle, what does that mean about these two segments? They are congruent, right? So we would write a line here and a line here. And we would use this statement here segment JL is congruent to segment NL, because that is the definition of midpoint. Alright, what is the next given information at the top? What does it say? JM is congruent to NM. Alright, yesterday we talked about reflexive. What does that mean, reflexive? When I was saying reflexive. Very good. It's the same side. This line right here would be an example of reflexive property because it's sharing a side. So we could say that line LM is congruent to line LM. They're the same thing. And that would be reflexive property. And then we would also have to label there to show that those three sides are congruent. So once you have proven all of those things, you can now look at the triangle and see that they have the markings for the side, side, side postulate. So once that's done, you can then conclude that the two triangles are congruent, which we would use triangle JLM is congruent to triangle NLM, and that is proven with SSS. Okay, so here we would call this the bow tie triangle. X is the midpoint of VZ, which is here. This is line VZ right here. And then X is the midpoint of YW. Sorry. Yeah, YW or WY. Okay, so the first given information, X is midpoint of VZ. And how do we know that? It is given Alright, what should my next, or what should I label on here based on that information? If X is the midpoint of YZ, what do we know about these two lines right here? They are congruent. So from there, at the bottom, which of these statements says that those two lines are congruent? Yes. Alright, so we would use that one next. Vx is congruent to xz. What reason would we use for that? Definition of midpoint. Very good. Very good. Alright. Okay, next I would go back up to my given. My next given statement is that X is the midpoint of WY. Alright, and that is going to be, again, given information. Okay, so since that is the midpoint of this line, that tells me that these two segments are what? congruent. So we would use that congruency marking for both sides. And then at the bottom, you're looking for the statement that tells me that those two segments are congruent. Does anyone know what that might be down here? WX is congruent to what? XY, which is shown here. Okay, and that is going to be, again, definition of midpoint. Okay, now we have to prove side angle side. So we have these two sides that are congruent. That means that the angle in between them must be the same. How do we know that these two angles are the same? They're what type of angles? Vertical angles. Very good. So we know that those are congruent. We can prove it because of the vertical angle theorem. So down at the bottom, we're going to use the reason angle WXV, okay, it connects, is congruent to YXZ. And that would be because they are vertical angles. With that, you can conclude that the two triangles are congruent. So you would use this statement here. Triangle VWX is congruent to triangle ZYX. And that is proven with the side angle side postulate. Alright, last one. Okay, so we have side angle side, proof 2. So we're doing 2 examples for each one. Alright, so on this triangle, or triangles, pair of triangles, I want you to notice here that they're sharing a side. That's something that you need to be noticing on these. So that's going to be the reflexive property. Somewhere is going to be used here. Okay, so first of all, it's telling me that XW is congruent to XY, which is here. So I'm going to go ahead and label that. I'm going to write it in, and I'm going to mark out given because that's given information. Okay, next, XZ bisects angle WXY. What does it mean if it's bisecting an angle? It's cutting it in half. So that means that these two angles here are going to be congruent because that line is cutting it in half. So we would write the reason first. That is given. Because that is given, you can then conclude that these two angles are congruent. So that would be this statement here, WXZ is congruent to YXZ. And that would be the reason of definition of the angle bisector. An angle bisector cuts an angle in half. Okay, so again, we're trying to prove side angle side. What is the side that needs to be proven is the same? Yes, very good. All right, it has to be this one because the angle needs to be included. It needs to be in between the two sides, which that's easy to prove because, again, it is reflexive property. This is the same exact line. So from there, you would say that line XZ is congruent to line XZ because of reflexive property. And then from there you can prove side angle side, side angle side. The two triangles are now congruent. So triangle WXY is congruent to triangle YXZ. Alright, so we're going to go ahead and move on to the next one, which is going to be angle side angle proof 1. So this is where we have to prove that an angle, a side in between the two angles, is congruent. So we're going to start with QR bisects PQS. So resulting from that bisecting, remember bisecting means cut in half, you are bisecting this entire angle. So what that means is that these two angles are now going to be congruent based on that information. So we're going to start with QR bisects angle PQS. Okay, so I'm going to mark that on the bottom, and also that is given information. Okay, from there you're going to go and you're going to say that these two separate angles are now congruent because of that bisect. So that should be PQR and SQR, which is down here at the bottom. Oh, that's a triangle, sorry, it would be this one. Sorry, it would be this one. That's not, we're not using that one yet. Okay, so we have angle PQR is congruent to SQR. Remember, this one was not correct because Q has to be in the middle. That's the angle, that's where the vertex is, okay? And then it ends at R. They both end at R. So that would be definition of an angle bisector. Okay, so from there I'm going to look at the next piece of given information, which is the one I actually marked out a while ago. PRQ is congruent to SRQ. So angle PRQ is congruent to angle SRQ. Again, that is given. Now I'm going to go back up here and I'm going to see which angle that would be. So PRQ, I'll connect the dots. PRQ is this angle right here. So that would get a different congruency marking because it's a different angle. And then SRQ would be this angle here. Okay? So if we are trying to prove angle side angle, these are my two angles. The side needs to be the included side, which is this angle, which is this side here. Again, this is easy to prove because it is a shared side, which again would be reflexive property. Okay, so that would be this line in the middle, which would be line QR. So we would say line QR is congruent to line QR because of reflexive property. Alright, so from there we can make our congruency marking and we can say that the triangles are congruent. So triangle PQR is congruent to triangle SQR because of the angle side angle postulate. Alright, so on the next one we have another angle side angle proof. Okay, so we're going to start with AC bisects angle BAD. So AC is this line, BAD is this angle here. So line AC bisects angle BAD. Okay, so that means that these two angles have to be congruent because it is being bisected. So I'm going to write given over here. I'm going to mark out that information, which is this one. I'm going to mark out given. That tells me again that those two angles are congruent, so I need to look for those. Remember, A needs to be in the middle, so it would be these. BAC is congruent to DAC. So we would mark that out. And that would be the definition of an angle bisector. Okay, next piece of information, AC, again same line, bisects BCD, which is this angle on this side. So this would get a different congruency marking because it's a different pair of angles. So we're going to write line AC bisects angle BCD, which is this one here. That is given. Okay, and that tells me that angle BCA is congruent to angle DCA. And that is again the definition of an angle bisector, because an angle bisector cuts the angle into two congruent pieces. Okay, last thing you need to prove is that the line that falls between the angles is congruent, which you should by now see that that is a shared line. That automatically makes that line congruent because it's the same exact line. So again, that would be reflexive. So AC is congruent to AC. So with that being said, you can now prove that the two triangles are congruent. So triangle BAC is congruent to triangle DAC because of the angle side angle postulate. So those are examples of angle side angle. Alright, so now we have two proofs left. We have angle, angle side, and then we have hypotenuse leg. So we have line SR bisects angle QST, which is QST, okay? And that is given. That's the first piece of given information. Okay? And then that means, that results in these two angles being congruent. So we have angle QSR, so that's this one, and TSR, which is this one here. So angle QSR is congruent to angle TSR because that is the definition of angle bisector. Okay, next piece of information. Angle SQR is congruent to STR. So that would be this one here. Okay, notice the vertices match QQ, TT. So I'm going to write that down here. Angle SQR is congruent to angle STR. That is also given. Okay. Last thing you need to prove is that the line is also congruent. So remember, angle, angle, side, the side needs to be across from the angle, or opposite. So this line right here would work, and we could say that they are congruent because of reflexive property. Once that is proven, you can now say that the two triangles are congruent. So triangle QSR is congruent to triangle TSR because of AAS. Alright, so I'm going to leave this one blank. You will try to complete that one. I advise doing it in pencil, and then we will come back once we're done with, everyone's done with all the notes, and we'll check to make sure that your answers are correct. Okay, so we're going to move on to hypotenuse leg next. Okay, so hypotenuse leg, remember, works for right triangles only. Okay, so it says QSR and TSR are right triangles. So I'm going to write my little right triangle here in the corner, my little right angle. Okay, so I'm going to write triangle QSR and triangle TSR are right. Okay, and I'm going to say that that is given, and I'm abbreviating because I can't fit all that in there. Okay, next I have, let's see if I can prove anything else based on that. I can't, so I'm going to move on to the next piece of given information. QS is congruent to line TS, again given. So I'm going to come up here and I'm going to mark that. QS and TS. Okay, so we know that this is the hypotenuse. Remember, we talked about how it is the line that is across from the right angle, so that would be my hypotenuse. And then this line is also going to be congruent because it is a shared side reflexive property. So this would be considered your leg that is also congruent. Okay, so we need to show that SR is congruent to SR. That would be, of course, reflexive. We've seen that enough. We've heard that word enough to where we're able to identify that. Once you're proving that at least one leg and both hypotenuses are congruent, then you can say that the entire triangle is congruent, which would be triangle QSR and TSR, and we could say that is congruent because hypotenuse leg. Okay, so again, I'm leaving this blank. So you're going to try, again, this is the word bank at the bottom to help you. So you are going to try to solve the answers in here. Again, fill it out with pencil. Up here, just remember that that means perpendicular. So that forms a right angle. From there, you should be able to figure out what statements and reasons go here. The rest of these we're going to wait on, okay, because I still need to explain what CP-CTC is, which isn't hard, but for now we're just going to do the 5 proofs that we've learned this week. So your job now is to complete this, and then we're going to come together and check it.